Hello everyone, myself Dr. Krishna Kumar, Assistant Professor, Department of Civil Engineering, SRM Madurai College for Engineering and Technology. So today's topic is vector operations, which comes under engineering mechanics. So to start with, to define what is a vector. Vector is a physical quantities that require both magnitude and direction. It is to describe both magnitude as well as direction of a physical quantity. So what is vector operations then? So vector operations is nothing but the addition of or multiplication of or calculating a combination of vector operations. So here are following are the vectors, types of vectors. Example: displacement, velocities, acceleration and moments. These are all examples for vector quantities. So to be continued, so here we have left side you have scalar quantities, on the right you have the vector quantities. Mass, power, energy, these are all falls under the category of scalar quantities, and for vector quantities it will follow a direction along with its magnitude. So displacement, so it has a magnitude as well as direction. Acceleration, velocity, force, momentum, torque, these are all the examples for vector quantities. So this is an example to define two different quantities, that is vector as well as scalar. So velocity is a vector quantity and speed is a scalar quantity. So velocity, as we know that it is the ratio of distance by time, and speed is also distance by time, whereas velocity will define the direction of the velocity here, whereas in speed there is no direction is mentioned, so it is a scalar, and vector in the sense it will define the direction in terms of velocity. So these are the basic operations we are going to perform with the vector: addition, as I told, subtraction, multiplication, and resolving a vector into components. So we can see that addition. So if we have two vector quantities, we can simply add one and the second one. So f vector is equal to f1 vector plus f2 vector, and subtracting is f vector is equal to f1 vector minus f2 vector, and multiplication is a dot product. We know that f vector is equal to a dot f vector, and resolving the component, we will always resolve the inclined force into two components, that is f cos theta as well as f sin theta, as shown in this picture. So components of vector, these are the components of vector. As we can see in this left image, that arrow is shown and a 500 Newton force is applied. So here the arrow head is called head of the vector and tail is tail vector, and magnitude of the vector is nothing but that 500 Newton. So magnitude is nothing but the intensity. So whereas arrow defines the direction, and the vector designation is, we will name the vector with some name, either it is a force. Example I'm telling, it's a force, or f, the term f. So all these things are vector designation. So here you can see a player, he is heading the ball in a football match, and he wants that ball to go in particular direction at particular speed, we can tell. So he's applying a force of 30 Newton, and here his desired direction is headed towards the arrow. So that is nothing but we call it as a vector, and the top of the arrow is arrowhead and the bottom is arrow tail. So to perform an operation, so either to add, we have two types of laws. One is parallelogram law, another one is triangle method. So parallelogram law and triangle method will get the same answer. Just we have just two ways to add a vector quantity. So a vector and b vector are two vectors shown in this diagram. So resultant vector r is equal to a vector plus b vector. And in case of triangular method, so again the same, here r is equal to a plus b, but just you have a parallelogram shape of vectors a and b, and here we have a triangular shape. So both resembles the same, we are just adding both the vectors. So vector addition, here we can see uh, if P is one vector and Q is another vector, R vector will be the addition of both P vector as well as Q vector following the same direction of P and Q. So that is very important. So P vector is following a direction and Q vector is again following a direction. So addition of both is the R vector, that should also follow the same direction of P, R and so or Q. And in case of triangular method, see again a similar resemblance, a vector plus b vector is equal to a plus b vector as a resultant, and a that is having same direction, and b is also having the same direction. So polygonal method, so here you have many number of vectors. Example, in the picture we can see a is a vector, b is a vector, c is a vector. So addition of all these vectors, all the vectors are following the same direction. Example, you can see a is following a direction, and the head of a is the tail of b, and head of b is the tail of c. So if the vector is following one particular direction, the resultant r vector will be opposite to addition of all these things, and it will be opposite to the direction of a, that will follow a different direction. So that is what polygonal of method. So r is equal to a plus b plus c plus d plus e, but it should be in the opposite direction. So how to resolve a vector now? So if you have a resultant vector f vector, and if you want to resolve into two components, the horizontal component we can take it as I, that is unit vector as I, and vertical component is y, that is lying on y axis, is we can call it as j component. So I vector and j vector, both vectors are called unit vectors. So we can resolve it and we can name it as I vector as well as j vector. So this is how we have to resolve a vector which is having an inclination with any one of the axis. So here we have an example again. So the same example is taken. So if it follows positive quadrant, so f is equal to fxi plus fyj. So I and j are unit vectors of x component and y component. Fx and fy are the resolved components of f. So you know how to resolve it. So when you resolve f in x axis, f cos theta will take, and if you want to resolve in y axis, you will take fy sin theta. Similarly, if it follows the negative quadrant, if y is along negative y is taken, we have to put a minus j, and positive I is shown here. So fxi minus of fyj. So again, to add two vectors, this is the example. So if we have a resultant vector fr is the resultant vector is equal to sum of fxi summation of fyj plus summation of fzk. So whenever you want to add, you should add only the unit vector components. Example, you can see here a is equal to axi plus ayj plus azk, and b is equal to bxi plus byj plus bzk. If I want to add a plus b, then the vector resultant is ax plus bx into I vector, ay plus by into j vector, az into bz into k vector. So here is an example for subtraction. So similar, the similar pattern of addition should be followed for subtraction also. And this is the Cartesian form. If we get the third axis, that is z axis, so this vector is called, can be named as Cartesian form. So here we'll get additionally one more unit vector, that is k vector. So this is an example problem to understand better, for the better understanding of the same. So here I have three forces. F1 is 300, F2 is 450, F3 is 600, and the slope of each forces is given 45 degree, and gradient is given for dy by dx is given, and Fy is also given. It is vertical, so it is 90 degree. So our target is to find the magnitude of the angle of the resultant forces. So what I have to do is I am resolving f1 into two components, that is I and j. So and f2 is again unit vector is added, that is minus 450 cos 45 degree into I vector plus 450 sin 45 into j vector. So again f3, that is third force is resolved. That is what we get is 360 into I plus 480 into j vector. So just we have resolved and we have written in the form of vector quantities. and resultant vector r vector, they are just summing of all the three vectors f1, f2 as well as f3 on summing up. So this is the relation we are getting. Fr is equal to Fr is equal to 41.80 I plus 1098 j vector. So the magnitude and direction, the magnitude is nothing but the intensity, we have to convert into intensity form. So for that, what we should do, we should take the square root of I component of I vector unit vector in x component, as well as square of the unit vector in j component. So that is the answer we are getting is 1099 newtons. And phi is the angle of inclination, that is resultant angle of inclination, tan inverse of fr divided by the x component, fx component, that is 41.8. so we get it as 87.8 degree. So I hope you have understood this vector operations concept. Thank you for watching. Thank you.